Hello guys, this is Srinivasrao Peluri, math educator. Yes, so today I am going to explain, right, permutation and combinations. It is very important topic for intermediate level or CBSE and complex track also. Complex track means aptitude. Okay, it is also very one of the important topic. Is a permutation and a combination. So actually, according to the mathematical definition is each of the arrangements that can be made by taking some or all of a number of things is called a permutation. I repeat, each of the arrangements. Actually, the meaning of the word permutation is arrangement. Okay, right. So here, the meaning of the word permutation is arrangement. And the meaning of the word combination is selection. So, according to the intermediate level or CBSE level, the definition of the permutation is each of the arrangements that can be made by taking some or all of a number of things is called a permutation. Okay, right. So, originally the meaning of the word permutation is arrangement. So, it is like this, denoted by NPR. NPR is equal to n factorial by n minus r factorial. This is the formula. NPR is equal to n factorial by n minus r factorial. So P means permutation beta. Now suppose I consider that pi P2. Pi P2 is equal to, according to mathematical definition, pi factorial by pi minus 2 factorial, like this. So this is equal to pi factor means 5 into 4 into 3 into 2 into 1 by 3 factorial. So 5 into 4 into 3 into 2 into 1 by 1 into 2 into 3. So this one cancel. What will get? 5 into 4. This is pi P2. Okay guys, pi P2 is equal to, after simplification what you will get? 5 into 4. So with respect to my notation is, permutation pi P2. 2 is there and 5 is there. 5 into 4, bus, enough. No need to apply this total calculation. 100 P2 is equal to, 100 into 99, bus. 100 P3 is equal to 100 into 99 into 98. No need to apply this factorial notation. Why? Because it is a time taking process. Okay, right? Yes. So here pi P2 is equal to 5 factorial by pi minus 2 factorial. So 5 factorial means 5 into 4 into 3 into 2 into 1 by 3 factorial. So 5 into 4 into 3 into 2 into 1 by 1 into 2 into 3. Okay, right. Factorial factors. Bus, enough. 3 factorial, 3 factors. 1 into 2 into 3. 4 factorial. 1 into 2 into 3 into 4. 4 factors. Okay, right. 5 factorial. 1 into 2 into 3 into 4 into 5. 5 factors. Just like this. Okay, right. So pi P2 is equal to 5 factorial by 5 minus 2 factorial. After simplification, what do we get? 5 into 4. So with respect to my method is very simple method like this. Okay, right? Pi P2 is equal to 5 into 4, 2 factors. Okay, right? Yes. Now next one is pi P3, 5 into 4 into 3, bus. Back. 5 into 4 into 3, bus. Next one is 100 P3, 100 into 99 into 98. 1000 P3, 1000 into 999 into 998. Bus, 3 factors. Enough. Right? Yes. Now what about selection? Selection is equal to, this one is NCR. C, selection. Combination. So this one is equal to n factorial by r factorial into n minus r factorial. This is the formula, mathematical formula. So I suppose that like this one example, pi C2. 5c2 beta. 5c2 is equal to yes 5 factorial by yes 2 factorial into 5 minus 2 factorial. So this is equal to yes 5 into 4 into 3 into 2 into 1 by yes 2 into 1 into 3 factorial. So this is equal to 5 into 4 into 3 into 2 into 1 by 2 into 1 into 3 into 2 into 1. This one cancel. What the conclusion? 5 into 4 by 1 into 2. So with respect to my opinion is like this, 5c2 is equal to 5 into 4 by 1 into 2. Bas, that's it. I repeat, 5c2 is equal to 5 into 4 by 1 into 2. For example, 100c2 is equal to 100 into 99 by 1 into 2. That's it. Hello guys, right? So here 100c2 is equal to 100 into 99. That is a permutation. By yes 100c2 100 into 99 by 1 into 2. That's simple. 1000c3 is equal to 1000 into 999 into 998 by 1 into 2 into 3, whatever the value. Okay, right? Yes. Now this is the difference between permutation and combination. So permutation is arrangement, that's it. And combination is selection. Whatever the definition, mathematical definition. Yes, mathematical definition is each of the arrangement that can be made by taking some or all of a number of things is called a permutation. What about combination? Each of the selection that can be made by taking all of a number of things is called right combination. So don't concentrate on the definition of the permutation and combination. Simply we have to concentrate only the meaning of the words permutation and combination. Permutation means arrangement and the combination is selection. That's all. Okay, right. So we have to follow this one. Now, so here, now actually the relation between these two is NPR is equal to n factorial by n minus r factorial and NCR is equal to n factorial by r factorial into n minus r factorial. N minus r factorial. Okay guys, now the relation between these two. So this one is NCR is equal to n factorial by n minus r factorial whole divided by r factorial. Got it? So this numerator value is equal to NCR is equal to NPR by r factorial. Now, so this implies NPR is equal to NCR into r factorial. That's it. This is the relation between permutation and combination. Okay, right? Yes. What is the meaning of that one? What is the meaning of that one? Okay, right. So here, NCR, that means select. We have to select smaller numbers in n members, total n members, and arrange those members can be arranged among themselves in this body is very among themselves in r factorial way. That value is equal to arrangement. First we have to select and arrangement. Okay, right. First we have to select, for example, one class contains, say simply, suppose 20 members. One class contains 20 members. Now we have to select, three members. So that means we have to select 20C3 into 3 members can be arranged among themselves in 3 factorial way. That is equal to 20 P3. That is arrangement. Okay, right. We have to arrange 3 members in 20 members is equal to first we have to select 3 members from 20 members. And arranged 3 members can be arranged among themselves in 3 factorial. That is the relation between arrangement and the combination. Okay guys, yeah, look at the board. NPR is equal to n factorial by n minus r factorial. N minus r factorial. Okay guys, according to the definition, mathematical formula. Okay, right. NPR is equal to n factorial by n minus r factorial. Okay, right. Now this is equal to n factorial is equal to n into n minus 1 factorial by n minus r factorial. Got it? Okay, right. So look at this. 5 factorial is equal to 5 into 5 minus 1 factorial. N factorial is equal to n into n minus 1 factorial. Right? So 5 factorial is equal to 5 into 5 minus 1 factorial. Okay, right. Just you have to acting according to the statement of the question. Right. So now this one is equal to n into n minus 1 factorial by n minus 1 minus r minus 1 factorial. Like this. Sir, is it necessary to write like this? Yes. Okay, right. N minus 1 factorial. Here n is there. N minus 1 is there. That's why n minus 1, r minus 1. Minus 1, minus into minus, plus 1. There is no change the value. Right. So this is equal to n into whatever this value. This value once to consonant this one. NPR is equal to n factorial by n minus r factorial. Okay, right. Yes, this one is replace n by n minus 1. N minus 1 factorial by n minus 1 minus n minus 1 r factorial. What about this one? N minus 1 p r minus 1. Hello guys. Right. So this one is, NPR is equal to n into n minus 1 p r minus 1. Or in other words, n into n minus 1. N into n minus 1. Right. So this is equal to n minus 1 into n minus 2 p r minus 2 and so on. Like this. Okay, right. This is one of the important formula. It is very important for formula for EAP set. Understood? NPR is equal to n into n minus 1 n into n minus 1 p r minus 1 n into n into n minus 1 p r minus 1. Okay guys, now n into n minus 1 into n minus 2 p r minus 2. That's it, etc. Just you have to acting according to the whatever the requirement. Yes. Now what is the application part? Okay, right. So NPR is equal to, look at this, NPR is equal to n factorial by n minus r factorial. In this case, this formula is applicable only when, like this, n greater than or equal to r. Understood? N is equal to r or n greater than r. Okay, right? Yes. Now listen to with respect to functions point of view, the number of 1-1 functions or injective functions from A to B. Yes, like this. F map, like this. F map A to B, right, be a function. Be a function. A function. Fun is very important. Without fun, you can't define a function. So here, let f map A to B be a function. Whatever the nature of the function, right? So here, A is called a domain and B is called codomain. Right? So let f map A to B be a function. And suppose if n of B is greater than or equal to n of A, number of points in B, the set B is greater than or equal to number of points in capital A. Okay, right. Set means How do you define set? A well-defined collection of objects is called a set. A well-defined collection of, okay. Well-defined means it must be a defined. Defined means it satisfies condition or conditions. I repeat, set. It is a very important role in mathematics, right? So set means a well-defined collection of objects is called a set. It is very important word, well-defined. Well-defined means it must be a defined. Defined means it satisfies condition or conditions. Okay, for example, one outside person can sit in your room. Actually, you don't know mathematics. So, is that person well-defined in this class? In that class? No. Why? Because you don't know mathematics. That is well-defined. Well-defined means it must be a defined. Defined means it satisfies condition or conditions. That is set. So here f map A to B, A comma B two sets, be a function, right? If n of B, number of elements in the set B is greater than or equal to number of elements in A, conditions apply. Okay, right? If n of B greater than or equal to n of A, then the number of possible, then the number of possible one function or injective function, functions from capital A to capital B is n of B permutation n of A. That's it. It is application part. Okay, right? Yes, P means permutation, arrangement. Now we have to apply that permutation condition on the functions. It is an interlinked question. It is very important for EAP set. Right? So let f map A to B be a function. Right? If n of B greater than or equal to n of A, sir, okay sir, I agree with you sir, n of B greater than or equal to n of A, okay, I agree with you sir. What about n of B less than n of A? Just wait, I will tell you. Right? If n of B greater than or equal to n of A, then the number of possible one functions from A to B is n of B, P, n of A. So this is very important condition, and this also very important condition, like this. Why? Because permutation is applicable only on n greater than or equal to r. NPR is equal to n factorial by n minus r factorial, n greater than or equal to r. That's why we have to impose on the sets capital A comma capital B such that n of B greater than or equal to n of A. Therefore, the number of possible one functions from A to B is n of B for P, n of B. It is very important for EAP set or local M set or Maharashtra set or Karnataka set, AS set, okay, MH set, etc. and so on and so forth. Right, beta? So n of B, P, n of B. This is very important. Understood? Right. Yes, next one. Suppose, sir, if n of B less than n of A, sir, what is the position? 0. Obviously 0. Right, beta. For options given, no. Once you check it, 0 is there or not. So the number of possible one functions from A to B is n of B, P, n of A. Okay. Once you check it, is it n of P is equal to n of A, or n of B greater than n of A, or n of B less than n of A? That is very important. 3 cases there. So suppose, for example, let capital A is equal to set of yes 1 2. Okay. B is equal to set of A B C. Right. The number of possible one functions from A to B. Of course, here number of elements B is equal to 3, and n of A is equal to number of elements in A is equal to 2. The number of possible, okay, right, one functions or injection, one function, one to one function, right, or injective function, okay, is n of B, P, n of B, that is equal to 3 P2. That is equal, just I told no, 3 P2, 3 into 2 bus. Okay, right. 3 into 2, that is equal to 6. That's it. This is the answer. Okay guys, right? So let F map A to B be a function, and if n of B greater than or equal to n of A, then the number of possible 1-1 functions from A to B is equal to n of B P n of A. Conditions apply. N of B greater than or equal to n of A. Example, let A is equal to set of 1, 2 and B is equal to set of ABC. Then the number of possible functions, the number of possible 1-1 functions, the number of possible 1-1 functions from A to B is equal to n of B P n of A, that is equal to 3P2 is equal to 3 into 2, 3 into 2. Actual generally formula is 3 factorial by 3 minus 2 factorial. That's it. So 3 into 2 is equal to 6. Look at the board. The number of permutations of n dissimilar things taken are at a time. Okay, right? Then repetition of things allowed any number of times. Okay, guys. Yeah. The number of permutations. Leave it that word permutation. Number of arrangements of n dissimilar things. N dissimilar things taken are at a time. When repetition of things allowed any number of times. Any number of times. Okay, right, is equal to, yes, n power r. That's it. N power r beta. Okay, right. So the number of permutations or arrangements of n dissimilar things taken are at a time when repetition of things, okay, allow any number of times, n power r. Okay, it is also very important for commutative track. Say for example, r places given, r places like this, 1, 2, 3 and so on, r places. n objects given, r places given, okay, right? n objects given. Here r places, 1, 2, 3, 4 and so on. n objects given. Yeah, first place can be occupies any one of, okay, right, n objects. Second place also n. Why? Because, okay, repetition of things allowed any number of times. Okay, right. So this also n and so this also n. So required, okay, permutation or arrangements is equal to n into n into n into and so on n. That is equal to r times. Yeah, simply this value is equal to how much? N power r. That's it. Why? Because for example 2 into 2 into 2, how much? 2 cube. 2 cube, na? Yeah. 3 into 3. This is equal to 3, just like that. Okay, right. N power r. Right. I'll give one example. For example, yes, 2, 5, 8, 7, right, 6, 4 objects given. 6 digits given. We can form 4-digit numbers. 4-digit. Yes. So 1, 2, 3, 4. 4 places given. We can form 4-digit numbers out of 6 digits. Repetition is allowed. So first place occupies, this one is 6. 1, 2, 3, 4, 5, 6. 6 digits given. Second also 6. Third also 6. Fourth also 6. So required permutation is equal to, yes, how much better this one? How much better this one? Yes? Yeah, n is equal to how much? 6. This is equal to 6 power 4. 6 into 6 into 6 into 6. Okay, 6 power 4. N power r. That's it. Yeah, guys. The number of mapping, that means functions. The number of mapping of capital A is equal to ABC into B is equal to set of 1, 2, 3, 4, 5. Application part for this one. So is, yes, n of B whole to the power of n of A. So n of B, number of elements in B is equal to 5. Number of elements in A is equal to 3. That's it, 5 cube. Application part. Okay, right. So the number of mapping capital A of A, B, C into B of 1, 2, 3, 4, 5. Or small correction, but this one, the number of functions from, understood, with respect to my notation, the number of mapping or functions from capital A of A comma B comma C to B is equal to set of 1 2 3 4 5 is equal to, yes, n of B to the power of n of A. Okay, right. What about one function? N of B permutation P n of A, that is one function. This one is number of possible functions. Excellent one. The number of possible functions from A to B is equal to n of B whole to the power of n of A. Sir, what about the number of possible functions from B to A? Yes, n of A to the power of n of B. That's it. Quite opposite. Okay, right. The number of possible functions from cat, especially in this question, is cat A is equal to set of ABC and B is equal to set of, yes, 1 2 3 4 5 is equal to n of B to the power of, okay, n of A. A to B, n of B to the power of B power A. Okay, right. B to A power B. That's it. Simple. Quite opposite. Yeah, A to B. Yes, n of B to the power of n of A. Right. B to A. So this is equal to n of A to the power of n of B. Yeah, these two are very important for commutative track. Yeah, listen beta. Next one is the number of permutations of n things. Okay, right? The number of permutations of n dissimilar things taken R at a time with at least one repetition is allowed. I repeat, the number of permutations of n dissimilar things taken R at a time with at least one repetition is allowed. At least one, at least, it is very dangerous word. At least one means, okay, right? At least one means more than one also. Okay, yes, that means, look at this, that is equal to n power r minus npr. The number of permutations of n dissimilar things, the number of permutations of n dissimilar things taken R at a time, with at least one repetition is, this one is most important bit better, this one. Okay, right. The number of permutations of n dissimilar things taken R at a time with at least one repetition is allowed. This one is repetition, this one is non-repetition. Total minus, okay, non-repeated, this one. Okay, n power r minus npr. N power r minus, okay, right, npr. So like this. So for example, yeah, please give me at least 10 rupees. Please give me at least 10 rupees means I am expecting more than 10 rupees from your side. That is very dangerous word, at least word. Okay, right. So here the number of permutations of n dissimilar things taken R at a time, with at least one repetition, is allowed is equal to how much beta? N power r minus npr. This one is very important bit beta, right, in commutative track. The number of permutations of, the number of arrangements of, both are same. The number of arrangements of n dissimilar things taken R at a time with at least one repetition is allowed is equal to n power r minus npr. At least, this one is very important. With at least one repetition is allowed is equal to n power r minus, right, npr. Right? Yeah, guys, one example beta. Then look at this. The number of arrangements of n dissimilar things taken r at a time with at least one repetition is allowed is equal to n power r minus npr. So I'll give one example. The number of four-letter words can be filled with any one of the word Mr. MISTER, in which at least one letter is repeated. With at least one letter is repeated. How many letters are there? 1, 2, 3, 4, 5, 6. Okay, right. 4, 5, 6. Yeah. 6, 6, 6, 6. 4-letter words, no? Right. Yeah. Yes. Now this one is, how many letters are there? So this is equal to, what is the formula? N power r minus NPR. So this is equal to 6 power 4 minus 6p4. That's it. 6p4. We can form 4-letter words can be filled with any one of the word Mr. in which at least one letter is repeated. That is equal to n power r minus NPR is equal to n is equal to 6. N is equal to 6. Why? Because 6 letters are there. 1, 2, 3, 4, 5, 6. 6 letters. Okay, right. R is equal to 4. R is equal to 4. That's it. So n power r minus NPR is equal to 6 power 4 minus 6p4. So whatever the value. This is the, okay, right? Answer better.